There's a very big demand for power all across the world. In many places with less infrastructure, it's harder to distribute power among the population. Nuclear energy seems to be the alternative and the answer for all the problems we're having around the world. If you're to take 1 pound of gasoline, you probably need micrograms of nuclear fuel to match that 1 pound of gasoline. Or not, to put in other words, if you're to take 1 pound of nuclear fuel, which is an isotope of hydrogen, deuterium and tritium, you would probably need thousands, if not hundreds of thousands of pounds of gasoline to match the energy output of that 1 pound of nuclear fuel. So how does nuclear fusion work? Well, nuclear fusion is relying on two forms of hydrogen, two isotopes. One is deuterium, which has one neutron in the nucleus, and the other one is tritium, which has two neutrons in the nucleus. These two atoms are combined to make helium and output one neutron. So, how does energy come out of this? Well, to cause two atoms to fuse, it's kind of like a chemical reaction, but instead you're not causing electrons to bond with each other. You're forcing the nuclei of two different atoms to form and fuse into one atom. And then the output of this is a lot of heat and one neutron. The energy it takes to break that neutron away from that one atom, from that one atom is enormous. It's a lot more than gasoline can ever produce heat-wise. So the way this is done is they take low-pressure vacuum chambers and then they feed these gases in there. They feed them in a pure gas form, and then magnetic fields induce a very heavy current inside of these gases, causing them to turn into plasma. When they're in a state of plasma, they start fusing and they start producing neutrons and a lot of heat. Well, the problem with this is that this plasma will get on the walls and melt the actual reactor. So what they do is they take other magnetic fields with huge superconducting coils, and they confine the magnetic field because plasma has its own magnetic field. So it's kind of like taking two magnets that repel each other, but you put them in a donut form, and then you got a big plasma donut. Sounds tasty, doesn't it?
The future applications of fission reactions is that you can have a power plant which is clean but also more powerful than our current ones. So the most powerful power plants we have now are nuclear fission powered. And a fusion reactor is 3 to 4 times greater power energy producing than a fission reactor. So, just to summarize, it would be a more powerful, more energy producing power plant that is also clean because it's not producing greenhouse gases and radioactive waste. That is the future applications of fusion. It is to make power plants to help produce our energy needs.